Hi class, welcome back to Computational Tools. Today we'll have our third and final Excel tutorial. And then after that you have the final project for Excel, and then we'll be moving on to MATLAB. So for today we're going to learn how to import data to Excel, and then you're going to be doing some plotting and you're going to make some tables. So I'm just going to take you through the first part of the tutorial together. So let's get started and let's look at our data. So I'm going to open up my Firefox here. And as you can see, my home page is NASA's climate change page. So you can see the vital signs for Earth down there. And we're going to go to usgs.gov. And USGS stands for the U.S. Geological Survey. And today we're going to be importing streamflow data to Excel, and we are going to be looking specifically at the Connecticut River at Montague City. So let's go to Science, and we are going to go down to Water under Science Explorer. And then once we're in Science Explorer, we're going to scroll down and we're going to choose a topic, and our topic is going to be streamflow. Okay, and so we're going to click on current streamflow conditions. And so you can see here what across the US what current daily streamflow looks like. So streamflow is volumetric flow. So it's a volume of water over time is what we're looking at. And so you could see this explanation, this legend down here shows us what the current conditions are compared to the last 30-year record. Okay, so looking at the average data over 30 years. So how does our current data today compare to the historic average? So in Massachusetts, where our flow is pretty high for this time of year, a little higher than maybe in the middle, like we're either green or blue. It's hard to tell up there. Actually, there's one blue dot that's in the greater than 90th percentile. But anyway, so what we want to do is we are going to search for our station. So let's just click somewhere near Massachusetts. Okay, and let's try to find our site. So we're going to be on the Connecticut River at Montague, which is going to be, that's Irving. There it is. So this dot right here, or you can also Google and search by station number. So the station number is 011705000. So let's click on it. Okay, so then we're looking at the gauge now. So this is data for gauge height, it's for stream discharge, and it tells us the location of the stream gauge, and it also tells us the area that it's draining. It tells us the period of record. So for discharge, which is our stream flow, we have data available from March 1904 to the current year. And so you could see an image of a photo looking upstream from the gauge and also looking downstream. So what it looks like if you wanted to go there and collect maybe water quality data to go along with it. And we can get a little glimmer at, so these orange triangles are the median daily statistic over the last 115 years. And then we also have our discharge over the past week, which is this blue curve. And that's discharge in cubic feet per second is what we're looking up there. But what we're going to do is we want to compare 10-year average discharge for 2010 to 2019 to that of 10-year average discharge from 1960 to 69 and 1910 to 1919. So let's start by getting the data for 2010 to 2019. So what we're going to do is up top near available data for this site, we are going to go to time series daily statistics. So this will give us an average stream flow for each day. And then the available data for this site is discharge in cubic feet per second. So we want that available data. And then down below, we want to type the date range for the statistics calculation. So we're going to type in its year, the 4-digit year, 2-digit month, 2-digit day. So it's going to be 2010-10-01. And the reason I'm starting in October is hydrologists, when they're studying stream flow over time, looking at stream flow over time, that is known as the hydrograph. And we typically look at it over the course of something called a water year. And a water year starts on October 1st. And so then we're going to go up to 2019, and we're going to go to the 30th of September. Okay, so 10 full years of data. And we want to make sure we're going to export this data as tab separated data. And then we're going to save it to file, and we are going to hit submit. All right, and I'm going to open this with a text viewer. And so let me just find my text viewer. There we go, text edit. So now you can see all the data. And I'm going to go ahead and rename this and put it somewhere I can easily find it. And I am going to call this 2010_19. It's going to save as a text file, and I'm just going to put it in my folder for this class. Hit enter. Okay, so now I'm going to get rid of that. And I am going to minimize this USGS site, and I am going to go back to Excel. I'm going to have A1 selected. Let me just make this a little larger so you can see. And I am going to go ahead and I am going to import data. So under File, I am going to go down to Import. And I am going to import a text file. And I'm going to pick out my text file, which it didn't save as a text file, so this is good. We're going to troubleshoot together. Let me go back and view that. So here's the thing. For some reason, it didn't save as a text file, so I'm just going to rename it .txt, add it. Okay, so now it's saved as a text file. Now I'm going to go back. I'm going to import my text file. Now I should be able to select it since it has the .txt at the end. So I'm going to get data. Okay, and so then it asks how we want to import this data. So this is the text import wizard, step 1 of 3. And so we have delimited selected because our data is going to be tab delimited. And we don't have to import all this beginning stuff. So we're going to start our import row where our actual data is. And so we're going to start at row 45. So I'm going to hit next. And we are tab delimited. Okay. And then we're going to hit next. General. And then we're going to do finish. And we're going to put it in our existing sheet in the A1 and hit OK. All right, so you can see we have all kinds of data that we don't need. So we have the agency ID here, so the USGS, our site number, so that's our gauge number, some bunch of other info. We have month, day, begin year. Okay, and you can see this is actually, the reason it's beginning in your 2011 here is because we started our import for October 2010, and so our first January would have actually been 2011. So if you actually scroll down to a different month here, so it imported from 2011. Okay, so we have our begin year, our end year, our count. And so then the thing that we really want is the mean stream the flow. That is going to be our column N. So what we want to do here is we are going to delete everything but column N. I know, after all that. So I'm going to just go through and highlight. And you can either select delete up here, or you can just right click and hit delete. And then everything past the mean, let's hit delete. And then what we want to do is we're going to rename that column. So let's merge and center this. And we are going to rename this 2010 through 19 QCFS. Okay, so it's in cubic feet per second. I'm just going to center everything. Okay, and let's rename this tab data. Now make sure you have this saved. So save it. And then I'm going to insert a row. So I can right click and insert, or I could click up here above. And I am going to merge and center above. And I'm going to type JD in here for Julian Day. And so this is the streamflow data for the 1st of January. And Julian days count from starting January 1st. So day 1 would be January 1st, day 2 would be January 2nd, day 3 would be January 3rd, and onward. So we are going to enter 366 Julian days because there are some leap years in there. Okay, so now we have our dates. And so we could plot a time series, a hydrograph of this discharge streamflow data versus Julian day. And we're going to do that as 3 separate series. So for 2010 to 2019, and then we're going to do that again for 1960 to 69 and 1910 to 1919. So now we have to do is return to our browser and export more data. And so this time we are going to go from 1960. Okay, and then we are going to finish up in 1969. Okay, and we are going to export this as tab separated data, save it to file. And I'm going to open it once again with our text edit. And I'm going to save it. And I am going to call it something similar to last time. So I'm going to call it 1960 through 69. Underscore 69.txt. And then I'm going to go ahead and go through the process of importing once again. So I'm going to go to File, Import, Text File, 1960 to 69, delimited. And we're going to start at row 45, tab, general, and we're going to start in C1. Okay, so once again, we're going to delete everything except for the average, which, let me find that, the mean, so that's P here. So I'm going to delete all of this and everything after the mean. Okay. All right. So then we're just going to merge and center. And this is going to be our 1960 through 69 discharge. So in hydrology, the symbol for discharge is Q. I know. So in thermodynamics, Q is heat transfer. In hydrology, Q is discharge. There are not enough letters in the alphabet for engineers or physicists or any of the above. So why don't you go ahead now and do this again and do it for 1910 to 1919. Repeat this process. And then when you're done, you're going to create a smooth line scatter plot. So showing each series in the same scatter plot in a new tab named hydrograph. So if you need a refresher of how to generate a plot in a new tab, look at the last few minutes of tutorial 2 video once again. So remember, this is going to be a hydrograph, so stream discharge versus day. All right, and then you're going to do a summary table in a new tab after that, looking at high flows, and that is just about it. So good luck on finishing this one up, and get in touch with me if you have any questions. All right, take care.